Hello, and welcome to Philip Brown's Computer Networking Lab. You're watching the instructional video called Multicast Embedded Rendezvous Point Configuration. We are looking at a simple diagram of a multicast server and a client computer connected together by three routers labeled A, B, and C. We're going to configure the multicast network with these components, and we're going to make router B the rendezvous point on this loopback interface. We need to use IPv6 to perform the configuration because IPv4 does not have this equivalent feature. If you're not familiar with IPv6, you should look at my video on the subject before proceeding. This video also assumes that you have either saw my previous video on embedded rendezvous points or you have some knowledge of the concept. Let's look at the commands needed to pass multicast traffic through the routers using the embedded rendezvous point configuration. In the global configuration mode, you will need to type the IP multicast routing command that will enable multicast traffic to be forwarded on this router. You also need to have the rendezvous point know that it is the rendezvous point by statically configuring the router using the IPv6 PIM RP address command. These are the steps that we're going to use to configure multicast using the embedded rendezvous point. 1. We are going to verify that the unicast network is working correctly. 2. We're going to configure the routers for multicasting. 3. We will configure the rendezvous point. 4. We're going to have a client computer request multicast traffic. And 5. We're going to have the multicast server send out multicast traffic. I have already tested the connectivity between the multicast server and the client computer earlier by using unicast ping packets. Let's configure all the routers for multicast routing using the IP multicast routing command. We do not need to configure sparse mode on the interfaces since it automatically comes with IPv6 multicasting. This mode is no longer used as an option under IPv6. We are typing the same commands in all three routers. It is time to perform the third step. The loopback interface on router B is being statically configured to be the rendezvous point on router B. And we will also advertise the address using OSPF. Let's configure the client computer to receive multicast traffic using the IP MLD join group command, followed by the embedded IP address. When the multicast server sends out multicast ping packets to all the client computers that are participating in multicasting, the client computers will respond with reply ping packets. The multicast is working between the server and the client computer. The embedded rendezvous point allows us to dynamically configure all the routers in the network with the location of the rendezvous point right from the destination address of the packet. I hope this video has been informative, and I thank you for viewing.